Welcome to the app, Calculating an Area of a Circle with Squares. Let's leave the app for a moment and see the formula for the area of a circle. Many students remember the formula as simply a series of symbols, pi, r, and squared. The goal of this app is that the students attribute a deeper meaning to this formula. So it won't just be a series of symbols. R squared will mean something, and pi will mean something. Now, we'll see how the app aims to achieve this. So let's choose a radius of 2 in manual mode. So we'll click 2, and we now have a circle with the radius of 2. And now the question is, what is the area of the circle? And we have the method we will use to discover this. We will attempt to figure this out by cutting the circle into pieces. We now click Next Stage, and the circle is cut. Now we click Next Stage again, and this square appears. We added a square with the side measuring the same length as the radius. So the area of the square is 2 squared, which is the radius squared. Okay, let's continue. You may click the center of the circle to rotate the square. Let's try. So we'll click, and the square rotated by 90 degrees. Okay, let's click again. And now we have an estimation question. You can ask your students, the area of the circle equals how many of these squares? Now, it's interesting to see what the students will say. You could also ask questions such as, could the area of the circle be equal to 5 of these squares? And the answer is no. We can then say that 4 of these squares, 1, 2, 3, and 4, would cover the entire circle, so the area of the circle has to be equal to less than 4 squares. So after the students give their opinions and you have a class discussion, we can click Next Stage. Now we have Write your estimation for the area of the circle using arrows. S represents the area of the circle. 2 squared is the area of the square. We can click the 2 to turn it into r squared if we want. We can click again to move it back to 2. We're now taking it as a given that the number of squares needed is somewhere between 3 and 4. Let's say, for example, that the students think that the area of the circle equals 3.5 of these squares. In this case, we click here for a prolonged period until we reach 3.5 or 3.5, and we see this represented visually over here. Now, let's click Next Stage for the final stage. And we have drag the circle parts into the squares to get the correct answer. Work right to left. Okay, let's do it. So we'll drag this square and put it here, and now this one, and this one, and this one. And one of these squares, as you can see, is full. Now, we'll take this part of the circle and place it here. And we'll take another one. Now, of course, we can't fill the square perfectly with these pieces, but look what happens. So we'll take this one, and we'll put this here, and this here. And the moment the total area of the pieces we put in the square exceeds the area of the square is filled, and it throws out a rectangle with the excess area that we placed in the square. Now we can place it in the next square and add more pieces. And one more. After 3 of these squares are full, the last square is divided into 10, as you see. Now, let's place this here. And in this square, it's as if the area just melts into the bottom. Now, let's place the last piece. Let go, and we're done. We see the estimation of 3.5 squares is too high, so we can now bring this number down and try to stop at the right place. Let's say here. As you know, as teachers, 3.14 is close to pi, and now we can click Actual Formula, and here it is. Instead of the 2 squared, we have the general r squared, and instead of the 3.14, we have pi. We hope this formula will have more meaning to the students. R squared is this square, and pi is how many of these squares together equal the area of the circle. Students may think that there's something special, though, about the radius of 2, so we could try another circle. So let's click New Circle. Let's click 3, and we have a circle with the radius of 3. We have the same stages. Next stage. The circle is cut. Go on to next stage, and we have the same r squared square and the same question. And click Next Stage. Now, let's say the students do estimate 3.14. Okay, and click Next Stage. And now we have to drag all of these pieces, of course, many more than last time. So we have more work to do, but we will, of course, reach the same result. We won't go through this process again. Instead, let's click New Circle. Now, going through the process with the radius of 4 could take a while, and that's why we have video mode. So let's click 4 over here. And here, instead of filling the squares manually, we can click Play and simply see a video of the squares being filled. So in this app, we're able to demonstrate the calculation of areas of circles with radiuses of 2, 3, and 4. And we'll reach the same result in each case. This, of course, does not prove the formula, but it gives the students a good intuition of what it actually means. So thank you so much for watching.